to get the maximal element to minimal element or greatest element or lowest element, we look at whole set in consideration, whole Hasse diagram in consideration. Upper bound, lower bound, these things are with respect to some subset of this set. Let's say if I have S1 is 2 and 3, then we talk like this: what is the upper bound of S1? Then we will get a set. Okay, what elements would be here? All those elements to which 2 and 3 both are related to. All those such elements will be here. What is lower bound of S1 then? Lower bound of S1 is all those elements that are related to 2 and 3. Okay, now, how do we find such elements? In case of upper bound, how do we find such elements? We look to find the join. So from 2 and 3, let's say if it was 2 and 3 in your Hasse diagram, 2 and 3 was like this, and then we look to see the first join. The first joining point, and from this joining point, whatever comes in the upper network, all of the elements will be here, right? And similarly, you may not have only one unique join point, you may have more than one join point. Means there's more than one join point. Let me show you something. Now you can see that this is J1, this is one join point, this is another join point. So from J2, including J2, every other element in the upper path will be there in upper bound of S1. So this is how we find upper bound. Okay, we look to find the join points. If you have more than one join points, then it's like J1, this is a join point, and then every element that is in the upward path from J1. J2, that is the join point, then every element because of J2 that comes in the upper path. That's how you can find out the upper bound. Now, if you have a unique join, means you don't have more than one join point. If you have a unique join, then that unique join is the least upper bound. Okay, so what I mean to say is this: for a given set S1, the upper bound may be an empty set. Okay, because you may find, let's say this also may be the case that you have 2, you have 3, and they don't have any join, they don't have a join point. In that case, the upper bound is 5. Let's suppose 2 and 3 both are maximal elements, then upper bound will be 5. So for a given set, the upper bound may be an empty set. There may not be any element, you may not find any element to which all of the elements of the set are related to. Okay, similarly, for a given set, the lower bound may be empty. You may not find any other element that is related to 2 and 3 both. Okay, you may find, let's say, 4 that has an upper path to 2 but not to 3. Or you may find any element like 4 who does not have an upper path to 2 or 3. Or 4 has an upper path to 3 but not 2. What I mean to say that you will not find any element X that has an upper path to 2 or 3. If you don't find any such element, then your lower bound is empty. If you want to find the lower bound of 2 and 3, let's say this is your point of meet. This is your first point of meet. In a similar manner, maybe there is some other point of meet. Okay, so if there are no meet point, then lower bound is empty. If there is unique meet point, then that lower bound is greatest lower bound. And if you have more than one lower bound, if you have more than one meet point, then you have lower bound, but you don't have any greatest lower bound. And what is greatest lower bound, you know that, and what is least upper bound, you know that. I have already explained it before. I just wanted to make a summary of it. So the summary is this. The summary is something like this: that for a given set, upper bound S1 for a given set S1, where S1 is a subset of S, which is a poset. So upper bound of S1 may be empty, may be empty set, or may not be empty set. Now, if it is not empty set, then the upper bound of S1 may have a unique join point or mm, multiple join points. If it is unique join point, then this is also least upper bound. And if it is multiple join points, then least upper bound do not exist. Similarly, for a given set S1, where S1 is a subset of S, what is lower bound of S1 may be empty. Lower bound of S1 may be empty. If lower bound of S1 is not equal to phi, then you may have a unique meet point or multiple meet points. And unique midpoint means this is the greatest lower bound. And multiple midpoint means greatest lower bound do not exist. Thank you very much.